qualified in the San Diego lab, Peter Mage, University of California, Santa Barbara.
So I'd like to begin by reminding all of you that you are unique and special individuals, each different in your own way, and that is a problem. Well, at least it's a problem in the field of medicine because of the way that different people respond to medications in different ways. This is something called variable dose response, and although that sounds technical, as many of you may remember from your college days, alcohol is a great example of the way that different people can respond to the same substance in a wide and sometimes entertaining variety of ways. But it turns out that this effect is even more pronounced when we start looking at potent medical compounds, like chemotherapy drugs that are used to treat cancer. Because of variable dose response, it's very difficult for doctors to determine the ideal drug dose for a given patient. They have to give enough so that it does its job, but not so much that it causes harmful side effects. And that's actually a really difficult balance to reach. Unfortunately, the current process for determining this ideal dose is more or less a highly educated form of guesswork, based on a variety of physiological and genetic predictive factors. This process, as it stands now, is costly, time-consuming, and for a lot of drugs and a lot of patients, just not very effective. But what if there was a different way altogether to think about delivering the ideal drug dose? What if we could take guesswork out of the equation by listening directly to what the body is telling us in response to medications in real time? Well, in my research, I've combined approaches from biotechnology and engineering to design a system that senses what a drug is doing in the body and controls drug delivery accordingly. Now, to do this, we need a sensor that can measure what's happening in the body in real time. And my group at UC Santa Barbara developed a chip right here, about the size of a disappointing stick of gum, that allows us to measure for the first time ever the concentration of drug directly in the bloodstream using special shape-shifting molecules that convert concentration to an electrical signal. This measurement is then converted to is then fed into a feedback controller, the same principle that allows a thermostat to keep a room at a steady temperature. And the details of all of this sound boring, but the exciting thing is this. For the first time ever, we can directly control the concentration of drug in a living animal. So this is real data showing the concentration of a chemotherapy drug in a rabbit. We can change the concentration over time, adapting from animal to animal, and we can even adapt the concentration to changes in the animal's physiology. Using this unprecedented capability, we hope that we can start to take the guesswork out of medicine, making existing treatments safer and more effective, and revolutionizing the field of personalized medicine in the years to come. So, at the end of the day, we may all be different individuals, but perhaps that's okay.